It's lesson 3 and we're still using one output. But that's about to change. We'll start using 2 and then 4, so the network can tell the car to go forward, backward, left, or right. Now, this is called a multi-label neural network. And you don't need to know this name to follow along, but I do want to tell some terminology, and don't confuse it with a multi-class neural network. A multi-class neural network is what we had in the machine learning course, where the drawing could be classified as one thing. But here, the network can say to go forward and left at the same time, for example. So it's a different thing. Okay, finally, the car will start exploring. Get it? Because the car is in the maze and no, 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 no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Open the playground from the link in the description and you're gonna see this scenario with 3 cars. But the difference is that now we also have the possibility to go in reverse. And I'm gonna show you how easy it is to solve this problem when we can do both of these things. I'm gonna set this weight here to -1. This one also to -1. And up here, the bias -0.9, like this. Now, this by itself crashes 2 of the cars, but if we also go on the right here and put the weight of 1, 1, and 0.9, essentially filling this remaining space and restarting the simulation, see what happened? Let's check this again. It looks really good. The cars are stopping where they should, and they are slowing down only when they need to at the very end. This one arrives first, this second, this third. If you just look at what happens here, it looks all right. And we don't have any curves or any fancy things, but what we do have is this other ability of the car to slow down quicker. So even if you could see a little bit of that kind of bouncing effect here, only for the fastest moving car, I don't know if you can even notice it. It's not a big deal anymore because this is such a powerful maneuver that it's basically making all of these points just follow this line separating the 2 surfaces here. And at the very end, you can see these things blinking like crazy because we're at the edge. This is a bit annoying here if you look at the neural network, but if you look here on the left, even if you zoom in, the cars don't really move because the acceleration is so small there and going in both directions. So I'm not really bothered by it, but if you are, you could set, for example, this to -0.89, and now there will be a small gap there. Maybe if I'm going to do this, you can see this very narrow gap here forming where the points stabilize nicely. Now let me show you the next homework. Go to s equals to rev_h. It's going to be the same thing, but just one car in the middle. And the goal for you is to make it do this, where the car goes up and down like that forever. Try to find a network configuration that does that. I think it's pretty cool. But now we're going to move on and I'm going to teach you about steering. So let's change the link at the top to s equals to str_0. And you're going to see this new scenario here. And the car has one more sensor, the one on the right. you can see this extra input appearing here, and it's now sensing something because the road border is quite close. But the other two are 0 because the car is not moving and because this is not sensing anything. Now here at the top, there are two new outputs for turning left and for turning right, and all these weights connecting them. Now these are really confusing to work with like that, so let's remove them from this button right here and move things around to make things a little bit clearer. So let's separate this into two parts. One on the left here will be what we just did previously, going forward and being able to stop so we don't collide. And then on the right, let's keep the steering part. It's going to work with this new sensor that we have here. And let's do the same thing that we did before. So let's connect this one and say here -1, and this one -1, and here -0.9. And for the reverse, 1, 1, and 0.9. Now this is the same thing that we had before, and the car should stop nicely at the end. And it did. But if you look here, something strange happens. Focus on this diagram, and when we refresh, crazy things are going on. This doesn't look anything like what we had previously, right? And that's because here we don't have the speed now, we have this sensor. If you click on it, it's going to change to the speed and show what we had before exactly, so now you can recognize this pattern here. But what were we looking at before? So this is what you're gonna have to understand next. It looks like these regions are somehow changing, but they're not. You can only change those things if you play with the weights and biases from up there. What happens is that this is really a 3D space now. And one axis that goes like that is the speed in this case. It's the one that is missing from these two labels here. And what we are seeing here is a slice of the cube at that speed, somewhere inside of this cube, at the value of the current speed. So if I'm going to change to this, it's like we are watching the cube now from the top. And what we see when we change this, we see the cube from the side. So this amount of green that is still on the right of this point is actually the same in this case. But as the speed of the car changes, this amount of green that we see in this other view is going to start growing and then shrink back. Because here, as the point is moving up, if you think about some kind of horizontal line at that point location, the amount of green on that line is growing and then shrinking again. So growing and then shrinking again. So this is what we see in this view. Growing and then shrinking again. It's not easy. Maybe it's going to help if we use Desmos again. And let's type in the functions. So we have -1x, -x, -1y, -y, and there is no weight connected to z at the moment, so I'm just going to put +0z. And nothing appears here, and this is because what we are describing now is a hyperplane. It's something in 4 dimensions. And here Desmos is saying something. Try adding an equal sign to turn this into an equation, because it can't show 4 dimensions there. So you could put equals, like equals to our bias, which was minus 0.9. And this now turns into a plane in 3 dimensions. But we're really interested in the values that are above this bias, so greater than minus 0.9. So what we have now here is essentially the gray area in our diagram, but let's look at it from the top, like so. Let's make it actually gray. It's possible to do that here. And let's zoom in here so that we focus on the -1 +1 area. And let's add the green one next. So that was x plus y plus 0z. We are not using that at the moment. And this is greater than 0.9. And this is our green area. Let's make it green so it's similar to ours. And it looks pretty much the same as what we have here, looking from the top. But if we look from the side, like this, and slice the cube somehow. I'm not sure if we can do that. Let's try going here in the settings. Let's try putting here 0. Okay, it looks like we can. So 0 means that we are basically having a 0 speed now. And the car has a 0 speed at the moment. Let's turn on this manual override. And when I go in reverse, you see this green part disappears from here. It disappears from there because when you have a negative value for the speed, like -1 for example, then we are watching this part, this slice of the cube that doesn't have any green in it. But if we go forward and increase the speed, we get more green appearing there. And that's because we are slicing more in front there. Like, let's say 1 would be very much maximum speed of the car, but let's put 0.5 for example. So this is half as much as the maximum speed. And let's see if we can get to that if I start all the way at the bottom here. So let's see how much green is coming here. Yeah, I could get to that, but I don't want to crush the car. I really hope this is clear for you, because these things start to not be very easy to understand, and the tools can only do so much. Now let's think about turning. So I want to turn based on this sensor here. If it doesn't sense anything, or if nothing is close, if the border is not close here, I want the car to turn to the right. So I'm going to connect here this sensor, and to keep things easy, I'm just going to put -1 here, and now vertically I can move that red region as a percentage. So this 20%, -20% here just means 20% upwards here. So let's move this all the way to the top, maybe -0.9 like this. And it's still off because this dot is above it here. But if I'm going to move the car somewhere where this doesn't appear, then it's now moved in this red area. So this will make the car turn. And let's see how it goes. I'm going to remove this manual override, and the car is turning a bit too much and then crashes in the wall. So maybe a value of -0.8 is better. Let's try to restart. Okay. Yeah, it looks like we got it to turn, so it's really nice. And see what happens here in the diagram. So what did we add, this red region? Let's try adding it in Desmos as well. So this one doesn't depend on x at all, it's 0x plus 0y. And minus z, because we have a -1 weight there, greater than minus 0.8. And we can change the color here to red, and this is what we get. Now, the option from here to have translucency, to see through these things, doesn't really work. When we have these solid objects, I think it shouldn't really work. It's kind of hard to think about these solid elements and seeing through them somehow. It's going to be very confusing anyway. But this didn't affect the other things. They are still there. If I'm gonna toggle it from here, it's just a new thing that was added. So here you have a combination of green and red, really. And that combination of green and red is what I'm showing here as this orange when they are overlapping there. The gray and red makes the red appear brighter like this. But from here you can actually remove some of these elements if you find them confusing. Like if you just want to see the red area here, you can turn off the gray and you can see it now well, and the green, and you can focus on what happens with the point and in relation to this control here. But let's turn them back on and change this to the previous view and see what is happening. So you see this crazy blinking that is happening there? It's because the point goes inside the red region and outside of the red region, sometimes really, really quickly. Here, when it's actually doing the turn, it's doing that. So what happens is the point is basically somewhere at the border here and then moving like that really fast. That's what makes everything blink red when seen from this side here. Again, really hope you get it. Play with these things, it really helps, I think. Now, if you look at this, something is weird because the car is not really driving on its side of the road, it's driving in the middle like crazy. So let's try to do that. Probably what we need to do is decrease this value here. Let's try going slowly because minus 0.9 crashed it. So I'm just going to try 81, 82, and focus what happens on the car as I'm changing this. 83, you see it got closer. Got closer, 84. It's getting closer, but it's also sometimes moving on this kind of trajectory that is probably going to hit the wall eventually. Let's see, 86. Almost hit there. Let's try 87. Maybe this is as much as we can go. Okay. So at 87, this thing happened. Basically, it turned in a way that it was on a collision course. And we need to correct for that. If it gets too close to the side of the road, we have to teach it to turn left. So let's connect this here and do the opposite. So -1 turns to +1. And then here we have +87. Okay, and probably it helps to switch back into this other mode where we can see now this. So red and blue are the two different sides. If it's not going to turn right, it's going to turn left. And if we restart, we see the car correcting itself. It's actually doing it like crazy. If you see here, very quick corrections happening. And that's because there's no spacing here. between the blue and the red. It also reminds me that in phase 1 of the course, some people were asking, why does the car shake like that? So now you have an answer. It was in between regions like this. Now it's better, it's on its side of the road, but it's touching that lane a little bit. I think we can do even better than that. So maybe let's try changing this to minus 0.9, like so, and this one to 0.9. So forcing it even closer. I think this looks good. If this shaking bothers you, then you can always put here a higher value, like minus 0.89, and now the car is not going to correct itself as often. Let's see how it does in a different scenario. So change here to str_1. And now you see the car going in circles like that. And this is what I meant in the beginning, that the right-hand rule in mazes doesn't necessarily guarantee that you're gonna get out of the maze. You can also get stuck in situations like this. So I just wanted to show you a situation where it doesn't work. Let's move on to a more complex scenario, str_2. And see what happens here. Something kind of crazy happened there, right? Let's look at it a little bit more. So these things are quite nice. It's really keeping its lane. And then here, oh no. Oh, even crashing, horrible. So let's look again and see what happens. Here, this is fine, but here it's doing something crazy. And that's because the front sensor doesn't see anything when moving here, but it saw something when moving there, so it slowed the car down. This is the problem here as well. The front sensor doesn't see anything, so the car only sees that it has to turn right, but it has large speed. And the same thing happens here. Picks up speed even more and then sees that it has to turn right, but then when the front sensor sees something, eventually it's too late for it to turn. Now, the solution for this is really to add more sensors, so that it can see things in front at different angles and figure out that something is coming. But I don't want to increase the complexity of this structure too much, because we will still add things to this, and it's going to become more and more confusing if we have more things to work with. What we will do is cap the speed, so that the car cannot go as fast as it can, but at a speed where this problem doesn't happen anymore. Think about it, the car sensing things on the right, really it finds out in the last minute that it has to turn. So if it's going some crazy speed there, it is going to fail. It's too late. So let's see how we cap the speed, and let's change here so that we see this chart, and let's remove blue and red because they are confusing. And let's remove these two links from here. We will do something else with the reverse section later. For now, it's best to focus just on this green area and cap it. So I want this section here to be black so that the car doesn't accelerate to the speed that it could manage mechanically. And for that, I'm gonna have to add here a new node like this. And let's just copy these values here. So -1, -1. And this one here is -0.9. And now these nodes are doing the same. So let's remove these links, put a 0 here. You can press 0 on your keyboard to do that faster. And let's connect these with some kind of positive weight, 0.1 for example. And you see this shape appearing here again. So now whatever this value is, this one is going to be the same. Now let's put this to 0 and create a new shape here that is just a horizontal flat line here and the bottom part gray. So I'm going to take the speed here only. It doesn't depend at all on this one, right? It's going to be a flat shape. And for simplicity, I like to put here -1. So here I can control a percentage. And let's try to put -0.4 and connect this one to the gray output and add some value there. So now this percentage here, if it's -0.5, it's exactly in the middle. This is higher, this is lower. Let's start at -0.5 and see if the car behavior changes. But we also have to do the combination. So the intersection between this region and this region, it's gonna keep just this kind of trapezoid here. To do AND, you put both of these to 0.1. And at the moment, this is actually doing OR, so it's either that or that. And here we can put 0.1. So that means that this needs to be on, this needs to be on for this one to activate. Great. And another homework for you would be to do the same thing for the green region. Here you would have to use OR, so it's a good chance to practice that logic. And you need to duplicate these, make similar logic, many complicated things, maybe clean this up a little bit, organize things differently, and connect in the same way to that one. Or do what I'm gonna do now and use the NOT operation. So what will happen is that when this one is on, this will be off. And when this one is off, this will be on, which kind of makes sense. I mean, when you drive a car, you typically accelerate or decelerate. You don't really let the car slow down by itself in almost any situation, unless you think about conserving gas or something like that. But if you want it to be fast, then you probably want to apply the brake if you're not accelerating. So having a NOT here does make some sense. And let's see how to do that. I'm gonna create another node here. It's easiest to teach you like this. And let's copy these values now. So 0, 1, 0, 1, 0, 1. And remove these other links, right-clicking. And 0, this one, positive here. So these nodes are now in sync. We have the same thing as before. We introduced another hidden layer here. And for the NOT, we are going to connect this one here with a negative weight. And here we have to use a negative bias as well. If you're going to use a value of -0.1, it will work, because when this is on, so a value of 1 multiplied by -0.1, so we do get here -0.1, and it's not greater than -0.1. So when this is on, this is not going to be on. But when this is off, then that's going to be 0 times something, which is 0, is greater than -0.1. So basically, we have a way here to get the opposite of this node. And that's why the green area is appearing here nice like that. And there's no overlap or anything going on. Like if you remove the gray area here, it's clear that the green is the opposite of the gray. Okay, so does it work? Let's restart. Still doesn't work. It's still going too fast there on that section. So we're gonna have to cap the speed even more. Maybe -0.3, let's say. And let's see what happens here. These were the most problematic things. And the car is going to go now quite slow compared to before. Yeah, it still did a little bit of a loop there. But it's not crashing anymore. So maybe even a smaller speed. Minus 0.2. Let's see if it crosses. No. Okay. It doesn't cross the line anymore. So with this logic, the car moves relatively slow to what it can do. But if you think about it, and if you would think that these are real cars and you're watching them from the helicopter or whatever, they would look like that. They wouldn't speed up crazy like what we had previously. So this is really a decent speed for a car inside of a city. So we did it. The car can now navigate these complex situations. It's even going on its own part of the road. And maybe it's a good time I show you these other buttons up here so you can save the current car network structure that we have here. We put a lot of work into this, so maybe we don't want to lose it. And saving from this button, and you can also load from this other button. So you can try different configurations, save them under different names, and then load them to see how they work in different scenarios, which, by the way, you can load from this button right here. So if you took the virtual world course, you have the editor there, and you can create any world you want for the cars to drive in. And you can use this playground to load those worlds into it and see this car or any car you build here manage it. Now, one thing that I still want to show you is that the network here doesn't look like the one I showed you in the very beginning of this course. Like if you type here default, the network here is quite different. It has just one hidden layer, right? And then this right sensor is connected to something here and to something there, not directly to these outputs. And there are significantly many weights here on the right. This is the common structure neural networks have, really, and the reason why everything on this line is connected to everything on this line, and here the same thing, has to do with how neural networks are represented internally as matrices and speeding up some of the operations and also a few other things I'm not going to get into. But basically, we could convert our network into this network by just adding zero weights where they are needed and making this kind of relationship here so that this node is in sync with this node and so on. The problem is this one more hidden layer is missing here, so how can this car do something here? And let's go back. I can show you that we can actually remove this node from here as well. So right click on it, connect like this, and just put here the 0.1, 0.1, 0.1. So now we have that gray area here, but it's covered by the green, so we can't see it. And the green has to be a knot again, but somehow created without that extra node from there. So we can connect this as such, put a negative 0.1 here, a negative 0.1 here, and it's not quite right here. This needs to be minus 0.2. I'll let you do the math for this one. But you can see the end result is exactly the same, and we didn't really need another node there, another hidden layer. Now you may want to save this version of the network as well, because it's different than the previous one. And what I'm going to show you next will kind of destroy it. So focus on this network here and change the URL to str_3. And notice that it looks different, but it's really the same thing. It's doing the exact same things as previously. Like you can recognize this shape here, and adding on these other two, you can see them here. Whatever network you create in str_2 is going to be converted in this kind of full network that you see here. And these weights are essentially zero, all of them that are added new, and you can recognize the other connections there. Plus these new nodes, two new nodes that are needed to connect to the turning right and turning left. And they are just in this kind of synced relationship. So whatever the node here is, this one at the top is doing the same. And this network looks much more like the one on the first page there. But that one had also some values for these weights. And the reason why that is that I optimized this network a little bit more by using the genetic algorithm. So I did this. I lowered the mutation here. And I tried to generate cars that are very similar to that one, but a little bit different so that maybe they act better. And this is really slow. Maybe it's acting a little bit better if we put this to the max. But basically, this is really slow because it's trying to process this larger network and do these visualizations. And yeah, but you can see this car that is leading here, the one that covered the most distance, is not the one that we previously had, that we were previously working with, because it has some values for these other weights. It might crash at some point, I don't know, but it's at least a car that is going, for now, better, faster than the previous one, the one we designed. And I think I saved one of these cars and I've used it as the intro there. You can see some of these connections here are still quite obvious that that the network is based on what we designed, but there may be some relationships between these nodes that we didn't even think of, and this network is potentially finding some of those. It's also making this much harder to explain what is going on. So this is the truth. Whenever you optimize using automatic methods like this, you will start to get a network that you can't explain every single thing from there. Usually you can't explain anything from there. But in this one, because of all the things that we have done, we do still have some idea of what is going on. Now, this car seems to be doing quite a good job. I'm going to save it. And let's close this and see it going. And it might be faster, but it's not as smooth as what we had previously. It's doing this kind of fidgeting here. Sometimes it's pressing acceleration and brake at the same time. But you see how these small changes in the weights are affecting the overall result, even though it's kind of doing the same thing. Some of these structures are totally different. So here there is not anymore that kind of separation. The gray area looks different. It's doing an or here now. It's not doing an and anymore. So probably, yeah, this bias here has been made lower. So this is interesting, an interesting change. And the green region is very much the same as before. So now this is not anymore when not braking, when not accelerating, you brake. It's also these two sections appearing here where both of them are pressed at the same time. And there's much more going on here. Like when the car is turning at some point, I noticed that the green region is, you saw that? It was changing a little bit. The other sensor is somehow interfering with the logic from the component that we had independent previously. And there might be some good reason for that. Like if you do see that it's empty on the right, maybe you want the car to brake because you don't want it to go crazy, even if the front sensor is not doing anything. So it is possible to come to some better logic, more complex logic, automatically like this. And here, this thing here is really strange. Before we just saw the clear separation between blue and red, and what is this thing? If we remove the red, you can see that this is actually blue appearing here. So the blue somehow makes this shape now. And it depends on the speed as well, if it's going to act like that. So depending on the speed, this steering left, which we only use to correct its direction, has a different effect. Hopefully with all this you can see that we can still understand some of the things that the car is doing, even though the complexity has grown, especially because it's based on something we created, but also because of the tools that we are using here and the understanding that we gained during these lessons. It's important to remember that this is a small network. I mean, compared to that deep neural network we had in the machine learning course, this is nothing. And the one there is nothing compared to powerful ones out there. So just imagine the complexity those can handle if ours can already do so much. And by the way, in case you're curious, I did teach how to implement that chart and the decision boundary plot in the machine learning course. The diagram that we're using here is that, but regions can also overlap because of what I said earlier. Multiclass, multilabel, remember? Thanks for watching and see you guys.